Hello everyone, welcome back to our YouTube channel Testing Gyan. This is our fourth video in the series of array data structure programs. The problem which we are going to discuss today is how to rotate an array in anti-clockwise direction or left rotate an array by given places. We will deep dive in both naive and efficient approach for this problem and understand how one approach is better than the other. So now let us begin. Consider this as our input array with array elements as 1, 2, 5, minus 1 and 10. Now if we are having x equals to 2, that is the places by which we want to left rotate our array, then our output will look something like this: 5, minus 1, 10, 1 and 2, where we can clearly see that every element is rotated 2 times in the anti-clockwise direction, that is left rotation by given places, which is 2 in this case. So now let us see the approach to handle this problem. So the approach 1 is like where we will simply do the left rotation by 1 for given number of places. That is, we will left rotate our array elements by 1 by x times. So if x equal to 2, then in our iteration 1, our elements will be left rotated by 1. That is, our array elements will look like 2, 5, minus 1, 10 and 1. After this, iteration 2 will start, in which our array elements will become 5, minus 1, 10, 1 and 2. So this way we have left rotated our array elements by 2. That is, we are simply doing the left rotation by 1 for the given number of places. So now let us see the program to handle this solution. So solution for this approach is very simple. If you see, this is my function left rotate our array elements by 1, which we discussed in our last video. And this is my function or my naive approach to left rotate array by 1 for x times, which is where x is the number of places for which we want to rotate our array. So in iteration 1, our array will be rotated one time, and then in iteration 2, our array will be rotated one time, and that way we have rotated our array 2 times in the left direction. So let us verify this solution. So this is my input array, and if I call this naive approach, you can see, and let us give x as 2, that is, I want to left rotate my array by 2 times. So now if I run this program, you will see our array elements will be left rotated by 2. So 5, minus 1, 10, 1 and 2, which is the expected output in this case. Why we are calling this approach as naive approach? Because in this case our time complexity is not linear, it's multiple of x or the places by which we are rotating. Because in left rotation by 1, we are doing the n traversals to rotate our array elements by 1, which we have already discussed in our last video. And then we are again doing it for x times. That is why we are having time complexity as big of nx and space complexity is big of 1, as we are not using any extra space. So now let us see the efficient approach to handle this problem. So the efficient approach for this problem will be using the reversing technique, where we first reverse our array elements between 0 and the x minus 1 places. That is, if you see in reverse 1, we are doing the reverse between 0th and 1, where 1 is coming from x minus 1 and x is equal to 2, so 2 minus 1 is 1. That is why we are reversing the elements in 0th and 1th index, so that way our output is like 2, 1, 5, minus 1 and 10. If you see, we have reversed 2 and 1, that is the array elements at 0th and 1 index. Then in second reverse, we will reverse the elements between x and n minus 1 index. That is, x is 2, n minus 1 is 4, because our length of array is 5. In this case, we will reverse these elements 5, minus 1 and 10. And if we reverse this, it will be like 10, minus 1, 5. So in this case, our output array will be 2, 1, 10, minus 1 and 5. 2 and 1 because it was in first reverse, and 10, minus 1 and 5, it was in second reverse. And in our third reverse, we will reverse the complete array. That is, we will reverse the array elements for 0th and n minus 1 index, which is 4 in this case. And if we do the reverse, we will see the output will be 5, minus 1, 10, 1 and 2, which is the expected output when we are having x equal to 2. That way we have left rotated our array in n traversals. Okay, if you see in our first reverse, we traversed array for x minus 1 places. Then in our second, we traversed array for remaining places, and in the reverse 3 we traversed array for complete length. And if we sum up all, basically we are traversing our array for n places. That's why we are having time complexity as big of n. Okay, now let us see the program to handle this solution. For this solution, I need a function to reverse my array elements. So if you see here, I'm passing my array as input and low and high index. Okay, that is the index for which I want to reverse the array elements. And then I'm using a while loop. When while low is less than high, I'm simply swapping the array elements, and then I'm incrementing the low index and decrementing the high index. This way, I am simply reversing my array elements for given indexes. Okay, now let us build the solution as we discussed. Okay, so public static int, we are returning an array. So this is our efficient approach, because as we discussed, time complexity for this solution is linear time. So we are giving one input array and we are specifying the places by which we want to rotate our array. Okay, so at first let me find the length of my array, which is array.length. Then I will do the first reverse between 0th and x minus 1 index. Then second reverse will be from x to n minus 1 index, and third reverse will be from 0th to n minus 1, that is for the complete length of array. And at the end we will simply return the array. So this is our efficient approach. Now let us verify this solution. ARR equals to efficient approach, and let's say x is equal to 2. Now if I run this program, you can see our output is 5, minus 1, 10, 1 and 2, which is the expected output for this input. So this way we have left rotated our array elements in linear time, which is the efficient approach. So I hope you guys have understood both the solution. In case of any problems or query, please let us know over the video comments. Thank you.